Hello, welcome to Maths with Jay. In this question, we're looking at the curve with equation y equals the hyperbolic cosine of x, or coshx, and we're going to find the length of the curve. So let's write down the formula for the length. So this is our arc length formula. So it's an integral, and we're going to be putting in the limits. So we're given that x is from 1 to log 5, the natural log of 5. So let's put in those limits to start with. And then the formula tells us that we've got to square root 1 plus the square of the derivative of y. And then we want a dx there. So we want to work out dy by dx. So when we differentiate the hyperbolic cosine, we get the hyperbolic sine. In other words, sine x. So when we square that, we get the square of the hyperbolic sine of x. And we need 1 plus dy by dx all squared. So that's going to be 1 plus the hyperbolic sine squared, or sine squared. And we've got an identity that tells us that that's equal to the square of the hyperbolic cosine, or cosh squared. So we know that we want to integrate from 1 to log 5 the square root of something that's squared. In other words, we're integrating cosh x dx. So integrating that gives us the hyperbolic sine between 1 and log 5. So then we need to think about what that actually means in terms of e, so that we can work it out in terms, we want the answer in terms of e, don't we? So let's just write that down. Hyperbolic sine of x is e to the x minus e to the minus x all over 2. And that's between 1 and log 5. So let's just give ourselves a bit more space to work. Right, so all we need to do now is substitute in the limits. So we've got, substituting in the top limit, e to the power of the natural log of 5 minus e to the minus log 5 all over 2. And then we're subtracting, and now we're just substituting in 1. So we've got e to the 1 minus e to the minus 1 all over 2. So we're nearly there. The only thing we've got to be careful with is this e to the log 5. So let's just remind ourselves of powers of e when they've got a log in the middle of them. So the general formula that hopefully you are aware of is this one. So if you've got e to the power of x times the natural log of a, then that's going to be a to the power of x. So in this case, the a is going to be 5. So we've got e to the x log 5 equals 5 to the power of x. So looking at our first bracket here, e to the power of log 5 is going to be 5 to the power of 1. In other words, 5. And then when we've got e to the minus log 5, well, we've got minus log 5. So that's going to be 5 to the negative 1. And that again is over 2. And let's just leave the other one as it is. There's not much we can do to that really, is there? Well, I suppose we could write e to the minus 1 as 1 over e. So to tidy this up, I think I would take the half outside a bracket to start with, and then just write 5 minus, instead of 5 to the minus 1, think of that as minus a fifth, and then we've got minus e, and then at this stage minus minus, so plus, and then 1 over e rather than e to the minus 1, I think looks better. So let's just give ourselves space for the last line. Right, so all we really need to do here is work out the number 5 minus a fifth. So that will be 25 fifths minus 1 fifth, so 24 fifths. And then you can't do anything, or I don't think it's necessary to do anything to the minus e plus 1 over e. That can be left like that. I guess you might want to multiply out the half times 24 fifths and write that as 12 fifths if you like, but you still need to have the half outside the bracket with the e and the 1 over e, so that's up to you. So that's one way of writing the answer.